Hi there, welcome to this physics tutorial. We're going to go ahead and solve the problem shown, and it relates to gravitational force. It says here, you are seated at a table next to your cousin who's 0.60 meters away. Find the gravitational force between you and your cousin. Assume that you have a mass of 65 kilograms and your cousin has a mass of 75 kilograms. So let's first find the equation for gravitational force. So there's an equation in your book or in your notes that I'm sure you've learned. F sub g equals g, which is our universal constant, times m1 times m2 divided by r squared. Now in this equation, g is what we call our universal constant. And it's always going to be the same number. It will always equal 6.67 times 10 to the negative 11th Newton meter squared per kilograms squared. Always, no matter if we're on Earth or Mars or the moon, this will be a universal constant. It'll always equal this number. M1 is the mass of the first object, M2 is the mass of the second object, and R is the distance between the two objects' centers. So in this case, they're 0.6 meters away, so our R would be 0.6 meters. And then don't forget to square it, that's a common mistake. And then lastly, Fg is our gravitational force, which is what the problem is asking. So if we list out everything that we know, let's say M1 is your mass, that's 65 kilograms, M2 is your cousin's mass, or 75 kilograms, and then like we said, our R distance, or the distance between you and your cousin, is 0.6 meters. So let's go ahead and plug this in. If we have Fg, remember that universal constant, or g, will always be the same. No matter where we are in the universe, it will always equal this number. Our first mass is 65 kilograms, our second mass is 75 kilograms, and then lastly, the distance between them, or our R value, is 0.6 meters, and we must square this number. Now when I multiply this out on the top and I divide by 0.6 squared, I end up getting a gravitational force of 9.03 times 10 to the negative 7th newtons. And that there is the gravitational force exerted from you onto your cousin, or exerted from your cousin onto you. And how we say that is the gravitational force between you and your cousin. So that's how you solve these gravitational force problems. See if you can try another one similar to this. Good luck!